Okay, I think we're at the top of the hour, so let's go ahead and get started. So Jess, you've let everyone in the room.
Everyone's here.
Welcome, everyone. My name is David Bliss. I'm the CEO of Faraday Microgrids, and with me is John Griffiths, the CEO of Context CA, an engineering and design firm that we collaborate with quite frequently. Before we get started with our next in the series of the Don't Panic webinars about the new mandates for power supply to California's skilled nursing facilities, I want to give a couple of acknowledgements. First, to the Mazzetti team, who's been our collaborator in this series and who's hosting this webinar via their Zoom platform. Second of all, to John, Mr. Griffiths, for being a participant in several of these and for giving us his expertise today on the technical design. And then finally, to the Goalpost team, who's been helping us organize content and work through the process, and specifically to David McAndrews from Goalpost and Jess Heyman from Mazzetti. So with that said, a couple of logistical things. If you have questions, please put them into the chat. We'll be happy to answer those later on. There's a Q&A function as well as a hand-raising function. We'll try to answer those in between each talk. John will give a talk, as will I, talking about some of the technical aspects. And certainly we'll try to get to all of your questions. And if there's any that we can't answer directly, we'll be happy to work with you subsequent to this webinar to answer those in some other fashion. Anyway, with all that said, let me welcome John Griffiths, who's an electrical engineer and has his own design firm, Context CA, and who's been involved in several of the significant breakthrough healthcare microgrids that we've performed, our team at Faraday. John, go ahead and take it away, talking about the technical considerations for SNFs.
Wow, great. Well, thank you, Dave. And thanks everyone for joining today at 11. I know, people busy schedules and you get inundated with these invites. So my goal here is to share some of our experience delivering these microgrids solutions and sustainable ones. But I'd much rather, and I think, David, you're okay if we have this interactive. So if you do have a question or comment, please put it in the chat and we will try and address it. So before we get going, we do have a couple of Q&A. Jess, did we get we have a poll, and just want to get a sense of where our audience is at in terms of participants, so we can tailor this as much as we can and meaningful. So I see it up there. Actually, I'm going to see if I can click it. There you go. If you are able to do it, if you could add it to the chat or to the poll, and we'll just see where we are. Okay. Okay. Give you a minute. This is like a quiz, right?
You need some background music, John.
Right. Okay. 3, 2, 1. Right.
Yeah.
Got it. So. Okay, well, thanks for those who have clicked on there. And so what I see is we have a mixture of facility owners and operators and facility directors, which is fantastic. You guys and you're the people at the front end having to deliver this. And we've got some vendors and others. So well, great. Well, thank you for that, and it's good to get us going. We had another question. I promise there's only two. Jess, could we bring that up, please?
Yeah, actually, we had looks like people responded to both.
Oh, okay.
We should see the results now. We have people's main concerns with regard to AB 2511. And it looks like cost being a slightly higher concern across the board.
Okay.
Second to that, really tied legislation, supply chain, and site and infrastructure constraints, but cost being so far the number one.
Right. Well, great. Well, just thanks for summarizing that, and thanks for sharing it. I think it's we being David, myself, Dave, Charles Bliss, and myself as an engineer. We're always trying to be mindful of that. So let's, as we go through this presentation, that's good to we'll sort of keep bringing that to the fore. And if anything we say here, you feel you have comments or questions, feel free to put it in a chat, and we'll try and address it. So with that, shall I'll jump in. I got hopefully a couple of slides. Try to keep them relevant to what we're doing here, and Let me get started. So bear with me. Here we go. We're using PowerPoint. Sorry, I'm not sharing the right thing. Okay. Good. So I always like to start presentations with why. Why was this? This is primarily talking about the legislation of AB 2511. And I think wherever we are, to me, this is why we have this legislation and why we're on this presentation is a recognition that we're going to have more and prolonged outages, and with that, you can't maintain patient care without having an alternate power source. So, maybe 20, 30 years ago or longer, yes, you could have operable windows, but, without power, energy, you can't administer even the basic services. And, I just more recently, we are in California in a seismic zone, and I've been just hearing the news, the tragedy in Turkey. And for me, again, it brings home, a lot of this we're dealing with today is the challenges from the utility public safety shutoffs and the utility reaching capacity. But, we can't lose sight of the seismic event potential and the prolonged outages. So with that, I often like to think, yes, we talk about cost, for the facility people here, you're operating your facilities, and then you've been, tasked with this additional compliance, and which is going to cost money whichever way you look at it. So it's a challenge, right? I'm probably stating the obvious here, but if you have an existing building, the challenges of connecting to that existing infrastructure, you probably have limited capacity, maybe in a lot of your systems, feeder, conduits, generators. And then we're going to talk a lot about sustainable microgrids that myself and David are passionate about delivering, but not every vendor, contractor, and architect and engineer are familiar with those systems. So we're going to talk a little bit about the challenges of the lack of familiarity, and then maybe a couple of things we'll try and do at the end to help reduce that lack of familiarity. But with that, I always think every crisis is an opportunity. So when we're looking at a renewable, obviously opportunity is to provide more reliable power to your facility and for the patients, for the residents. And I'm sure there's a skilled nursing facility in my future, could be me. But when we looking at delivering solutions about backup power, if we look at it providing sustainable microgrids, or as part of that, as opposed to a generator, we'll look at taking the opportunity for the ongoing savings. And I think maybe I'll leave that to David. We can talk more about that. But I'm going to try and focus on, as an electrical engineer, what does it take to deliver it? Other advantage, I believe, of a sustainable microgrid, or it's always on. And then conversely to that, generator, great at providing, deployable, cost-effective emergency power. However, it's only on when you do testing, and then oftentimes you find out when there's a problem, when the utility goes off and you don't have backup power. So kind of a small, but I think important factor. And the other one is a seamless transition. A generator, again, great, that you have up to 10 seconds till the generator, you lose power. It depends when it happens. Generator starts and transfers. But in that 10 seconds, depending when that occurs, it can be, from my experience being in facilities when we're testing or you lose power, can be somewhat disruptive. And again, preaching to the choir here, but what does that mean? So if it's at night, you're without lights potentially for up to 10 seconds, your doors close, your fire smoke dampers close. And then if you have HVAC systems and IT systems, they have to restart. So, invariably that takes time, but just adding to the disruption of, trying to keep, the patients or sort of residents here happy and safe. Whereas in a sustainable microgrid, always on seamless transition, most of the systems will transfer go from being connected to the utility to an island microgrid in 100 milliseconds. And that's actually set by the PUC. But, we have a Powerwall system here at our office, and even I, as an electrical engineer, can't notice that blink when it goes. So with that, I am just framing this. And again, if you have any questions, I'm going to just jump into Jamie Schlick, who is the HCI electrical technical lead, has produced some great slides. So what I'm going to try and do here in the next ones is just run through the electrical single lines that Jamie had talked about before, but just highlighting the things that will change. So we've got 4 examples, and you can see my mouse moving. So, this would be excuse me, let's say what we have here, let's call it a traditional skilled nursing facility electrical distribution system. So we have the utility coming into your electrical distribution system. Let me just pause there. Can you see my mouse moving? I'm sort of pointing at it. I'll assume you can.
Yes.
Great. Okay. So utility comes in, goes out to the power. You have your generator. So what's different? So if you made this system comply with AB 2511, so one, you have to refeed the HVAC loads. Transfer those over from the normal power to the mustn't say emergency power to the let's call it backup power. And then you need to make sure that instead of you need 96 hours of fuel, that could be on site, or you could have a full service to provide that. And then you also need to make sure that things haven't previously been connected, such as like saving equipment, generator, need to be connected to emergency power. So what does that mean in the real world? Okay, facility people and engineers, you probably know that. But to me, if somebody came to me about this project, I would think, okay, refeeding HVAC. My takeaways would be, okay, we can transfer the circuits, but it's not just the HVAC. Chillers, typically the biggest load in a building. That means big starting load. And then also the controls. If you have a design team or a design build contractor coming on board, we need to just make sure that you've transferred the connection to the equipment, but also all the various components that go there. Controls. I know some facilities you may still have pneumatic systems, or you need to make sure all the outstations for the BMS are all connected. So when the generator comes back up, you're able to power and operate and control the system. Again, just maybe seeing minor points, but just when I was reviewing this legislation, and both myself and David on the Hospital Building Safety Board, I'm actually the electrical representative. These are the things that was come out in our other discussions. So quick summary, well, not very quick, but good summary and my takeaways. So let's jump to the next one. So this is, I forgot to move my mouse. There you go. So this is skilled nursing facility, and then this is another solution. So similar to one we had before, one generator. Now this solution would be adding a new generator to support supplementing the existing one that you have. So new generator, new HVAC panel, new transfer switch, new connection to your board, and then refeed your load. So, and adding fuel either on site or have a fuel service. So as an electrical engineer, is providing advice to my clients, what would I see here in terms of this solution? So electrical, new panels, new wiring, new disruption. And then if we're going to bring off a 200 or 400 off a main panel, you need to make sure a panel has capacity. When you're connecting to this, you need a shutdown. So there's cost and disruption to your facility. But with the generators, you have 2 generators on site. So, again, we're in California, so any generator needs to comply. You have emissions, so you need to do the air quality requirement. So when you submit the air quality permit, adding a generator. Any generator installed in California now has to be tier 4. So there's some very sophisticated emissions systems required. And when you do the risk assessment that the air quality district do, they aggregate the emissions from all the generators on site. So if you have a lot of generators, they're going to take that all as your site, run a risk assessment, and then they do an algorithm that says the likelihood of causing a carcinogen, percentage of increasing the risk of a carcinogen to, if you're close to a school or a sensitive area, that would increase it. So why is that relevant to this conversation? You would need to add the, you need to make sure you have diesel particulate filters or emissions treatment on this one, which will be because you're tier 4, but you may have, heaven forbid, have to add it on an existing generator, which could be very disruptive. So sorry, I'm getting a little bit into the weeds, but just thought these are things that come to me that I would share. So, all right, let's jump to the next one. I'll keep speeding up, right? So things that we're more passionate about. A microgrid parallel to the utility. Let me just pause there a second. So the legislation is, is well-intentioned, that was published, and the intent, the way it's worded, is guiding, the language I read is encouraging the use of sustainable microgrids. California has a net zero goal, and when we're delivering, we being the engineer, design, and developer community, we have an obligation, I think, both ethically, but also by code, we have to deliver sustainable solutions. So how do we do that? With generators, yes, our biofuels available, but hopefully we're looking at microgrids, and let me just come into the term microgrids that are using sustainable. So there's a lot on this diagram. So let's see if we can unpick it and make it relevant for this conversation. So, first thing is, what we're seeing here is pretty much the same diagram as we go back to this one, right? So you've got the utility, you've got a energy source, and you've got boards, and you've got some form of transfer switch. So if we jump back to this one, so instead of just one generator, so we've got an existing generator, and then we've got this, we've got potential connection to, these are, let's call it, think about these as distributed energy resources. So we've got, it could be a fuel cell, a solar back coupled with a battery, micro turbine where you're going to use typically gas, and you can also get the heat, use heat to use the waste heat to heat your hot water and domestic hot water. So this is the term, maybe your takeaway from this is distributed energy resource. And you have a controller, which is really important. Controller, there's a lot of innovation happening in that, but there's also a lot of code requirements. So facility loads required by the under electrical code, but also additional requirements under AB 2511. Okay. Takeaways. I would encourage people to think about this as distributed energy resource. I see in the chat cost. So generator, the term is stranded asset. You make the investment. The only time you realize that asset is in an emergency power. Really important, great technology. I'm trying to phrase that I'm not, we're not anti-generators. Generators are great, but we're trying to encourage our clients and hopefully those on the call here to look at other renewable resources. So generator connected, what I see here, and then we've got, just think about these as a collective resource. And I'm going to talk about some other projects in a little bit more detail. And then the term we're going to talk about later is hybrid inverter. This is not a hybrid inverter, but just think about how that, when we look at the other slides, how that relates to this. So takeaways, right now we need to be seismically certified with 96 hours of fuel provision. So as much as I wish, there are very, very few renewable products. We've got fuel cell, Bloom have a system. So it needs to be the equipment, but plus the fuel storage. So if you have gas, you need to have the tank seismically certified, the fuel cell, and the controls, and the same for the other devices. There are seismically certified microturbines, but if there's any vendors and manufacturers on the line on this call, I would highly encourage you to accelerate getting it seismically certified so we can specify and install them. Okay, so this next one is really just an evolution of the one before. Is instead of the generator, the microgrid is actually acting as the emergency power source. So 24/7, this is providing distributed energy resources, saving money. And I think David will talk about that as opposed to the traditional. If you have a new build, there's no available funding for this, grants or IRA money. Whereas this system, and I'm sure David can touch on that, there are various grants and incentives for these distributed sources for addressing the cost. So, I'll go over this, things we talked about, but so 96 hours. Getting 96 hours battery, that's right now is a challenge. But hopefully if we couple it with a fuel cell or even a temporary generator, we can get there to 96 hours. So with that, I'm just gonna so those are various diagrams. They're kind of technical, but we'll share the notes, and if you can skip through the recording if you do want to go over this, and again, or if you want to, feel free to call us. So I'm going to relate it to a couple of projects that we've delivered as a Contact and Faraday team, and sort of show this is possible. Right? So I'm looking at the time here. I'm at 20 past. Jess or David, feel free to tell me to hurry up, or I'll just keep going with this.
No. Keep going, John.
All right, thank you. So this is the San Benito Community Clinic in Hollister. We delivered this a couple of years ago. Right now, it's not a skilled nursing facility, but I think a lot of concepts are relevant to this discussion. So we utilize there was an existing generator. One of the first things, and I haven't heard this in these AB 2511, is looking at reducing the loads. We did some energy retrofits, LED lighting, improved the HVAC, and then which improved the resilience. And then we provide, which on this particular project, I feel particularly proud. It's providing sustainable power to an underserved community. So I feel that this is an amazing project from many levels. We can talk about that after this presentation, but the underserved communities are often the receiving end of much of the worst effects of climate change. So one thing I'll just come back to here is reducing load. Now on the HVAC side, the chillers, as an electrical engineer, I got to provide 96 hours of backup for that chiller. That's a big load. So a lot of projects, and I think there's a lot of talk about air source heat pumps, VRV systems. I'm English, in Europe, we're very familiar with those, but we're seeing a lot more of those becoming a lot more cost effective. So in terms of a traditional skilled nursing facility, imagine you have package air handling units on the roof, or if you have a large chiller, those are big loads, and they're providing large cost-effective air conditioning to a big space. Whereas with a VRV or using air source heat pump, variable refrigerant system, you're able to provide finite control to a set space. So for 96 hours, let's take this to extreme, you could just cool the IT room, the medication, and the specific spaces that you have to. You're not cooling all the other ancillary spaces, the lobbies. So that, to me, in the design, again, a lot of facilities are existing as an opportunities that we should really look to when we're designing systems. All right, so I'm going to keep going here. Sorry, I'm aware I'm talking a lot. I have a big note here. It says talk slowly. So if I'm going too fast, please let me know. All right, so next one. This is the first hospital microgrid in California. I probably say sustainable microgrid. I'd probably say the first in the US. David brought this to California, and kudos to him for that. But so this is a California Energy Commission funded project. It's actually connected to an high occupancy building, Kaiser Richmond. It's not a skilled nursing facility, but I just wanted to share a few things about this because I think it's relevant to this conversation. It is possible to connect to an HCI building. It was installed and commissioned without interruption to an existing facility. And this is a busy facility. This is not an underutilized facility. And if anybody's familiar with the Kaiser Richmond, it's a very well used facility. And we're supporting existing infrastructure, and it's providing ongoing energy savings day in, day out. And then again, there's a lot of advantages about that and how you commercialize this as an energy asset. And I think David will talk about that. Right. So the next one, Kaiser, Ontario. This is going to be our next iteration. I think all of us on this team are involved. Faraday are the developer, California Energy Commission funded. I'm providing electrical engineering services, as is Mazzetti. So largest sustainable microgrid, I would say, in the world right now, and it's able to support the entire facility. An amazing project. I'm really proud to be part of it. David, I don't know, you have some great pictures of the equipment going in on site, and I think it's on both of our websites if anybody have any interest. But just want to share, where this is going. Systems are coming available. This again is a full Kaiser template hospital. It is going to be supported by distributed energy assets. All right. So the next one, I'm going to get into a little bit more detail with this one. Hope I won't send you to sleep, but my goal is to make this relevant to your business, cost, delivering these solutions. So this is a pediatric practice in Marin. It's not a skilled nursing facility, but I think it's very relevant to this conversation. So we're going to use Second Life batteries, and we're able to support the entire facility. And we're going to make that connection without minimal impact to the facility. Let me pause there. So in terms of the scope, it was a former Chase Bank. It's repurposed into a pediatric practice, but it is their goal to keep this practice operational during a PSPS and any other events. It's a pediatric practice, right? It needs to provide, by code, it's not required to have emergency power, but from a programmatic and a community delivering services, it's critical in the community what it does. So just pause there in terms of Second Life batteries. Again, this is going to be a CEC funded project. We're actually going to use Nissan Leaf batteries. So a lot of times there's questions about sustainable lithium-ion batteries. What do you do with them? How do you recycle? Well, this is a great example. There's an abundance of them from dismantling yards. They don't know what to do with them. So the firm Repurpose Energy we're working with are going to take them, test them, and containerize them to provide the storage and battery to support the facility. And just to my takeaway, I actually met with the CEO and the founder, a great guy. But a car battery, as opposed to a one that you may have used for distributed energy resources, this is a really high performing battery. It's designed to operate at multiple temperatures because it's in your car. And because of a car, it's got to accelerate. It's got to be able to deploy energy at a really rapid rate. So really what you're getting is a much higher performance battery in the system. So with that, so what I thought I would do is detailed engineering review, AC theory. Well, sorry, I'll try and save you that. But this is the single line from the project. What I haven't seen in other presentations, and I was actually reviewing a project yesterday for another project providing a decarbonization study on, was, really good engineering firm, but when I looked at the way they had their electrical system laid out, it wasn't optimal for the developer who's building the building. So if I can just share here, I put some lines on here just to kind of communicate when you think about these drawings. what you should be looking for and how it works. So with that, I'm just going to take a drink of water a moment. Oh. So hopefully we've got these lines. So how does this work? So what I'm showing here is normal. We've got normal power flow. So we've got utilities in green and we've got the microgrid power. So normally power comes, I'm showing power going in and out, and we'll talk about that. So normally the power would come from the transformer through the main switchboard into the facility. Whereas what we're doing here in a lot of microgrids, and let me just pause there, definition of a microgrid is a building or a system that is able to be isolated from the utility, isolated from PG&E, and to be able to power itself. That's it. That is a microgrid. So in its purest sense, and that could be a generator, it could be a coal-fired plant, oil burning, as long as it provides power on its site, that's a microgrid. If you burn coal or oil, it's not a sustainable microgrid, but it is a microgrid. So this thing here, and I've got it covered up, is a utility disconnect. So what that does is power comes in through the transformer. We're going to take it out from the transformer through this. This is basically a switch. So when it senses you lose utility, it opens and islands the project. So we're talking here about normal power flow. Okay, I don't see any questions. Either I've sent you all to sleep or I'm answering your questions. So power comes in through this switch, which is closed normally, and then I skipped over it. You have to have a utility disconnect. This is required by code and that will go depending on the use of availability of the distributed energy resources. Will come through the utility, feed the building loads. But we have a microgrid, so this whole thing here forms a microgrid. So the power will come through the utility, and sometimes you can take it from the utility, and then you could do, I guess the term is energy arbitrage. You would charge the batteries when it's cheap, and then deploy it when it's energy is expensive. But as in this case, so we're connected through. Let me pause. So utility comes in to there, but the way this is sized, this building is going to use, if nothing, we'll probably be able to export energy because we have a great solar system. There's great solar exposure on this site. So, right. So power comes in through the utility from the microgrid. So how does this microgrid work? So we've got solar panels. So the solar panels are going to generate energy. That's going to go one way. So that's going to go through the inverter. That's going to convert DC power to AC and then export AC power out into the system, into the building. And then we've got batteries. So the batteries, you see the arrows go both ways. So the power, it can take, the solar can charge the batteries when there's available. And then the batteries can decide to use the solar power to charge them up and then deploy when it's needed to power the batteries based on time of use, price of energy, but also based on the if it's on the microgrid situation. So I use the term hybrid inverters, and I'm sorry I'm talking a lot here, I recognize that, but I just want to make things that I've found describing these projects that may be relevant to those in the audience. So we've got these things called inverters. So if you have a solar panel on your roof, you have an inverter. So that takes DC power in from your solar panel, converts it to AC into your building. And AC is what your houses run on. DC is like from batteries, what your cars run on. So this is a hybrid inverter because it can pass power both ways. It can take energy in and deploy it to convert it and charge the batteries, but it can also take multiple energy resources. And we have three. This is actually the diagram for the project. And as you can see here, this is how it operates normally. I've got the controller, and we can talk a little bit more about that, the importance of it, but that's really the brains. If I can jump to the next one, because I realize I'm going long, is same thing. So what happens when the utility goes off? So hopefully nothing. You just like seamless transition. If you lose a utility in a PSPS or rolling blackout, so the power goes, this opens, so there's no power coming from the utility. So depending if there's sun available, it could go directly through the inverter into the building, or the batteries would then deploy. If there's more solar than load, the energy will go in to be absorbed into the batteries and stored and deployed at night when there's no solar. So come back here, and then when the utility resumes, it would sense that the utility is back. This would close, and then we'd have a connection to the utility. Again, the way this is sized, there's probably almost no power coming this way, but we are able to export power. Again, so you do have an option, and I really think that if you have a generator, there's a concern, if you're in the Northwest or other areas where you don't have good solar exposure, is to connect to a generator. So if you have a hybrid inverter, we had that system in one of the earlier slides. I don't know if I can sort of swoop back to that, just show you here. So this is in fact, let's call this this is not actually an inverter, but it's part of a hybrid system, because it's taking multiple energy resources in and supporting the facility. So these, in fact, like off-the-shelf hybrid inverters, but you do have the opportunity to connect to generator. And I think one of your takeaways, many of you may already notice, is if you connect a generator through a hybrid inverter to a system, we're actually doing that at San Benito, is normally a generator connected to a building, a generator is sized on the biggest load in the building. And typically that would be an elevator or a chiller because it needs that capacity to start and run that motor. What does that mean? That means typically a generator is oversized for its normal running. A generator typically runs between 30 or even 40% of its rated capacity. So that means you're not fully utilizing the asset, but it also means if you have a limited amount of fuel, it's burning it at a very low efficiency. Generator's optimum efficiency is in the 70 to 80 range. So you're going to get, a lot more kilowatts for your gallon of diesel. So I think any takeaway you have from this is hybrid inverter and a generator. So let's say we've got no sun, or there's a problem with the solar panels. We've got a big load, it's really hot. So we run the generator. We say, okay, the batteries are getting deployed. There's no sun. We need to deploy the generator. So generator starts. And what the generator does, it's going to run at maximum efficiency. Let's say it's 80 or 90%. So that's going to provide power to the building, but it's also going to, whatever's left over from the building load is going to charge the batteries. So if this connected to gas, and the gas available, that's fine. But if you have a limited amount of diesel on site, you're going to get a lot more kilowatts from your gallon of diesel by connecting it to a hybrid inverter. A lot of them, Enphase and many of the manufacturers are actually providing that ability to do it. So if you're selecting a system looking at a renewable, this is going to get you to 96 hours pretty quickly. And you can even have a really small generator. I've seen some facilities where you have, let's say, a 20 kilowatt solar system, and you have a Generac generator in I guess what they call them, a zombie box. It's like a size of a large suitcase with a gas connection. They're installed for about $12,000. That buys you a lot of peace of mind. I've actually never seen them run, but you connect that to a hybrid inverter, and you're able to meet it. So with that, that's me. I've been talking for nearly 40 minutes. So in summary, what have we been talking about here? Really recognition that we're going to have more prolonged outages. You can't maintain these patient care without having alternate power sources. And, I think compliance is an opportunity. Right? We should look at embracing the funding. These new resources and assets are coming on the market to deliver sustainable and reliable power for now and in the future. So with that, I will hand over to David.
Okay, thank you, John. And by the way, while I'm getting my talk ready to go, if any questions arise, please feel free to put those into the chat box and we'll address them. I did want to say, as a bit of housekeeping, we are going to have an entire webinar devoted to the finance piece of this. So I will certainly touch on that and give information as we go, but it will not be the depth that you will get in 2 webinars from now. The next webinar is going to be in early March and will be a town hall bringing in a number of folks from significant stakeholder organizations. So we hope to have representatives from different state organizations, from environmental groups, from the advocacy group for skilled nursing facilities, and perhaps even legislators. So stand by, you'll hear about that subsequently.
Okay.
I will try not.
David,
Sorry.
sorry for interrupting you. Go, Jess. I saw a message that says chat is disabled.
I saw that. I think it looks like the Q&A is working, the Q&A
Okay.
feature. So for now, if folks can put their questions in the Q&A feature versus the chat.
Perfect.
Okay, great. Thank
Sorry
you.
for the technical difficulties. So we had intended this to be a technical deep dive, and I think John has provided a great deal of that. And some of what I'm going to show you are frankly some of the same slides and at the peril of being redundant. So I'll try not to just simply restate what John said, but give you a bit of the developer's perspective and some thoughts about cost and execution. We'll do a little bit of a deeper dive here into technologies. I did want to give a few definitions, and I want to give credit. All of these slides that I'm going to show you are taken directly from Jamie Schnick, who's the senior electrical engineer at Healthcare Access and Information Agency. I directly stole from him because these are so good and cover the necessary information. So I won't read slides to you because I find that to be annoying when people do that, but you can see that there's any number of types of theoretical alternate resources that you could employ, not all of which are ready for prime time at the moment, at least not for seismic certification. So as John talked about, this is sort of the conventional appearance of what we see in any skilled nursing facility. You almost certainly have, if you have the appropriate level of acuity, you have some backup generation set up, but it would be very unusual for that generator to be set up to cover all loads throughout the entire facility. In other words, it's likely that you have certain boards within your facility that intentionally are in effect electrically disabled when the utility is no longer available, and those aren't functional. So for example, one of the things that HCI has highlighted as a result of this legislation is it may very well be that environmental systems like HVAC, which are going to turn out to be necessary now, were considered necessary items in the past. In other words, might not have been wired to be supported by your backup generation. And so in this sort of scenario, they would be isolated. It's also important to note, by the way, that we're picking HVAC as an example here. It really is that the law specifies a safe temperature and safe environmental conditions. So you have to be between 71 to 81 degrees Fahrenheit, regardless of where you are in the state. So that may be that you need cooling, it may be that you need heating, it may mean that you need airflow, it may mean filtration. There's any number of other features of this. So HVAC is merely a stand-in, if you will, for systems that will need to be electrified in alternate power circumstances. And it actually, in your individual facilities, there may be any number of types of loads that will have to be rewired in that regard. So the point of this slide is merely that you could rewire whatever systems you wish over to this now essential branch, so that you're no longer isolated, but you would need obviously electricians and electrical engineers to come in and design how to do that and make sure that your existing generator has the load capacity. And then finally, you would have to have a means to store fuel. I should add in that regard, and John alluded to this, the 96-hour fuel requirement has some nuances to it. You can have a 6-hour on-site storage and 90 hours of available energy or fuel resource delivered to the site. So whether that is in the form of additional diesel fuel, electrical energy, or gas, or any other resource, I think that the state will be relatively agnostic so long as it meets safety requirements and the highlighted some of the other environmental concerns depending on the fuel. But almost certainly you would either have to enlarge your existing fuel capacity with additional underground or above ground tanks, or you would have to have a reliable fuel delivery system. So again, this is just a sort of a closer up highlight of what the current systems are serving and how they are currently isolated from one another in a lot of facilities. So if we move on, the solution that seems simplest, and in many respects, I think from a technical perspective, and John certainly discussed this, this is perhaps the easiest to design insofar, and I say this respectful of the fact, I'm not an engineer, I'm not an electrician, I don't have the expertise to be able to tell you how to do this. You know, we are the developer, builder, and financier of these sorts of projects. But I think we all understand that generators are a more than 100-year-old technology. The sizing and specifications of generators are relatively well set. They're seismically certified if you buy the right ones, and the fuel capacities requirements are known. So if one wished to, you could simply have parallel systems here. You could have one that serves your standard loads as you are already configured, and you would have to have backup fuel for that resource. And then you could add another generator into this panel in order to serve these other loads, again, HVAC being an example. The beauty of this is its simplicity. The difficulties are many, and I would start with, we've been hearing that there's upwards of a 72-week lead time between ordering and obtaining certified diesel generators. Not diesel generators in general, but seismically certified diesel generators. And as the demand skyrockets for a variety of reasons, we may see that get worse. I suppose it could get better if the manufacturers start to make more of these generators soon. But it is a concern that you could have a design completed but not have a method to build it. So again, just a little bit of emphasis on how each serves its own system. And then we move on to these alternate sources. So again, I won't read this slide to you, and John alluded to this. In essence, a microgrid is simply a more sophisticated aggregation of several resources that serve the loads at a given facility or campus. In this case, we're usually talking about a single facility for a nursing facility, but it could be multiple buildings. And so it's designed and built for the specific needs of that location. It doesn't necessarily have to be the same resources every time. It's really a matter of tailoring that to each individual circumstance. So Jamie has put together this nice slide that John already showed you, and I won't go through the technical aspects in the way that John did, except to point out that those resources that you're seeing within the microgrid are really intended to be any number of things that could be put together, both as energy generation, energy storage, and deployment, and then all of the control systems, all of the integration systems, all the things that make this function basically autonomously. And if you do it with the type of control system that we put into our microgrids, then you actually also have a remote team that can be monitoring and making sure that systems are healthy and safe at all times. It is worth pointing out, and I want to acknowledge this at this moment in time, that if you were to go out on the market and say, what could we get that's seismically certified? To my knowledge, and I think John will support this, there's no batteries, no fuel cells that are seismically certified currently, and no photovoltaics either. And there's some layers of complexity beneath that, because all support systems that go with those have to be seismically certified as well. So any of the inverters that John was talking about, or the other connections. There are other tools like combined heat and power, microturbines, et cetera, that do have seismic certification and could potentially be plugged in to this sort of environment. And several of us, including the Faraday team, are looking at what we can do to get these things seismically certified. One of the things we've talked to HCI about is whether there will be an option to design and be prepared to install these systems when they are seismically certified as adequate demonstration of the pathway towards meeting the requirements of the law. Because the law says you have to be up and running, if you will, January 1st of 2024. And I think most of us recognize that that's a very ambitious timeline at very best. So one pathway we're discussing, and I can't say that either HCI or CDPH has even reviewed this, much less approved of it, is to work with skilled nursing facilities and try to design, engineer, and be prepared for the build out of these systems while we're running the parallel path of getting them seismically certified. So along those same lines, you could have this microgrid in theory operate the entire facility and dispense with diesels altogether. Now, I say in theory because the alternate resource, as it's currently defined by CMS, et cetera, and I think it's important to mention CMS requirements. CMS really sees this very narrowly at the moment and requires that there be a diesel in the current setup. There is no requirement that diesel be the alternate resource in this new law. That's a very important distinction. In other words, you're not violating CMS principles as we read it by adding a microgrid to support loads that otherwise aren't defined by CMS as required. But you can use a microgrid as the sole alternate resource for these other loads that CMS is not concerned about, so long as the microgrid meets the seismic specifications. So this scenario is not a present day scenario, because as you see, the EDB branch would have to have a diesel to meet CMS requirements for the moment. But we strongly believe that this will be the future once microgrids have been proven to be adequate. And by the way, code changes are coming nationally that will reflect this. The NFPA, NEC, and other sort of important codes, and for that matter, HCI codes will probably undergo some evolution in this regard too. So we fully expect CMS will follow after all of those, and these come in. Yeah,
David,
please, John.
I just build on that, because I think that, I didn't say in terms of the Richmond, which is our first microgrid working together, they were very supportive of this, and Jamie, they actually have a working group within HCI pushing this forward. But I think the other thing my takeaway is CMS work even more slowly than HCI, but there's actually a group, there's a liaison that HCI meet with CMS, so they're pushing CMS as well. Because I know we can advocate as engineers and developers all these cool systems, but if you can't get licensed and you can't pass CMS, this is no good. So there are changes coming, hopefully.
Now, I will finish just with one financial comment, and just to sort of tease the discussion that we'll have at our two webinars from now. So if you look at the setup of this microgrid, in particular, if you were to focus on photovoltaics or batteries, or certainly the combination of the two, new federal legislation from the end of 2022 makes this a far more financially attractive approach. It was already very financially attractive, and I'll explain briefly in a second, but it's become even more so. So in brief, John said, and entirely correctly, that diesels are, at least from an economic standpoint, a stranded asset. You purchase it, it sits there, does very little to help you financially, but it serves an important safety function. Now, if you invest in photovoltaics, batteries, et cetera, these reduce your energy consumption from the utility, and they do that in two ways, right? They not only produce energy, but the batteries allow you to time shift it so that you use it at the time when otherwise energy is the most expensive from the utility. And at the same time, what you do is cut your peak demand, because those two periods overlap, the highest energy cost and the highest demand costs. So I would encourage you to go back and look at your energy bill for your skilled nursing facility, because a lot of medical facilities are paying upwards of 40%, if not more, of their monthly utility bill to demand fees. And you can cut those routinely, and that's what we've done at the Kaiser facilities, and that's what's being done at the other healthcare facilities we've mentioned. So that's a non-trivial thing to begin with. That's an asset or a benefit that the microgrid brings. Add to that now the Inflation Reduction Act has increased the tax credits up to, in some cases, 50 to 70% of the cost of the system. So if you were a low-income community and serving those sort of populations, and this was done the proper way, and there are some nuances to this. The developer, the builder, has to do this with prevailing wages and use U.S. manufactured materials, and has to be in certain types of communities. But you can at least get a 30% tax credit, and again, upwards of 50 to 70% tax credit up front, and depreciate the assets in a very accelerated way. Roughly, you could depreciate upwards of 60% in year one, and the remainder over the 5 years. So there's very few capital assets that you can depreciate like that you certainly can't depreciate the generators in that way. So it's a huge win, and even if it's not something that's within the capital budgets of a lot of facilities, there's plenty of financiers, for example, that we would be happy to bring to the table, who will finance these entire projects to obtain the tax value, sell the power to you at a cheaper price than you might pay the utility by far, and everyone leaves that arrangement in better shape. So apart from the requirements the new law sets for alternative resources, I would encourage you guys to look at your own costs and think about whether these options could help you knock those costs out significantly. I would add parenthetically, we'd be more than delighted if you want to communicate with us offline about your facility to take a quick look at what your current usage of energy is, your peak demand, and what your sort of electrical layout is, and sketch out what a system like this might look like, might cost, how the tax equity is handled, et cetera. We're more than happy to work collaboratively with folks and try to find a solution that best suits you. So with that said, I'll curtail things here in the interest of time so that we can get back to any questions that people have, because I think there's plenty to discuss here. So I'll just hand back the mic, so to speak, or stop sharing, and let's see if we can go to some of the questions.
Dave, looks like we have a question from Ken. Are you able to see that in the Q&A?
I do. Yeah.
Okay.
So hi, Ken. How are you? What class of seismic certification is necessary to meet the requirements in the new law for alternative energy resources? So Ken, I'll say, John, I don't know if you're an expert at that. I don't pretend to be an expert. Do you want to comment?
Yeah, as far as I'm aware, there's only one seismic certification, and that's it's given it's in the building. The requirements are in the building code. Gosh, I'm going to murder the acronym, but yeah, as far as I'm aware, there's only one seismic certification.
So I think, Ken, I'm aware that there's different seismic testing that you can do. There is one specific standard for the state of California for this specific purpose. And actually, if any of the HCI folks are online, we're more than happy to have you guys comment. So Ken, let me get back to you with a more accurate answer to that question. I don't want to ignore it. It is a relevant question. What I can tell you is, at the bare minimum, what's required is shake table testing to a specific seismic rating, and then proof that the system continues to function at its normal behavior back at the manufacturer. In other words, manufacturer ships to the shake table performs the testing according to the protocol. That's then has to go back and be validated by the manufacturer. But the specific label to that, I don't know, and I'll try to look that up and get that to you.
Well, David, can I maybe just add a couple of things? So I think there's a lot of equipment that, there's a recognition that the things that need to be seismically certified under the building code, that list is increased. There's a recognition that you can have the generator or the different components, but to make sure that equipment operates after a major seismic event, that was when the control panels needed to be are now to be seismically certified. We just pause there, but things that are like boilers and I'm trying to think the other equipment, there is a classification that they're robust equipment is recognized that they don't need to be seismically certified. Just on that point, I had hoped that in the legislation that, this is a state one size fits all, whereas with a building, the structural engineers design the building to the seismic forces in that area. So if you're right on top of the San Andreas fault, obviously you need a very robust building and other areas. So that's not in the legislation. It probably as a taxpayer of California, wish it was, but yeah, these are long answers to your question. Hopefully we gave it.
And I think, Ken, to add one more nuance that I didn't fully understand until I started to investigate this myself, is any significant modifications to the components or the performance of a system means it has to be recertified. And the certification of one type of system, so for example, if you said a racking system for photovoltaics, if you certify one racking system, does that apply to all racking systems of that type? The answer is no. Every manufacturer has to go through its own process. So the same would be true of each panel manufacturer, each racking manufacturer, each inverter, any of the switch gear that goes along with that. So that would also apply to each fuel cell, et cetera. A nuance I'm not clear yet on, but I'm working on, is whether if you have clearance for seismic certification for, say, a 25 kilowatt device, and there's a 50 kilowatt version of that is essentially two of those devices daisy chained together, not by the installer, but by the manufacturer, is that considered two of the same components, and therefore approved, or because it's manufactured that way, it's now a different device. I suspect it's considered a different device and has to go through separate testing, but I'm still trying to pin that down.
Right.
But great question. Thank you. Well, we've hit the top of the hour. I really appreciate everyone signing in and participating and listening to us, and we hope it's been helpful. Again, we're grateful to Mazzetti for hosting this and to Goalpost for helping to organize as well. Please join us. I think it's March 9th, I believe is what we set the date, but their notifications will go out for the roundtable discussion with a very broad range of stakeholders. And if, by the way, any of you consider yourself to be members of that community of stakeholders and would like to participate as a member of the roundtable, please reach us in whatever way you wish, and we'll be happy to incorporate you, because we want to have as many voices in the room as possible. And lastly, as I mentioned, we'll be doing a deep dive into the finance of this subsequent to the March 9th webinar. We haven't set the date yet, but we will get deeply into opportunities for financing yourself and using the tax equity, going through third parties for the tax equity, or even if you're a nonprofit, how you can benefit from the tax equity directly, because there is a provision for that as well. So thank you again for your time. I apologize, we ran about a minute over, but we're grateful for you for your time on this important subject. And thank you, John.
Yeah, thank you, David. Thanks all. Bye.